Hello everybody, I am going to be doing a lesson on finding inflection points. And the basic definition of an inflection point is finding a point in a graph where the function changes concavity. Here is a visual, a graph where it starts concave down and then turns concave up. So that point right in the middle is where the graph changes concavity. And basically, finding inflection points goes hand in hand in the process of finding concavity. So here is the first example. F of x equals x cubed minus 6x squared minus 12x plus 2. And the first step, you have to find the first derivative. So here is the first derivative. It is 3x squared minus 12x minus 12. Now, you need to find the second derivative. And that is f double prime of x equals 6x minus 12. In the third step, you need to find where it is undefined or equal to 0. So basically, all you have to do is set 6x squared minus 12 to 0. And you get x equals 2. Now, x equals 2 is a possible inflection point. So we have to test whether it is an inflection point. So that's step 4. Determining whether it is an inflection point by plugging in a larger number than 2 and a smaller number than 2 into the second derivative. So here I plugged in 4 and got a positive number, and for the smaller number I plugged in -2 and got a negative number. So if you put that into the graph here, it's concave down on this interval because it's negative, and on this interval it's concave up because it's positive. So your graph will somehow be looking like this, concave down to concave up. So this point right here is inflection point. So number 2 does prove to be an inflection point. The second example, f of x equals x to the 4th power. So the first process, you find the first derivative, which is 4x cubed. Second step, f is to find the second derivative. F double prime of x equals 12x squared. And you set that equal to 0, and you get x equals 0. Now, you plug in a larger number than 0 into the second derivative, and here we have a positive number. Then you plug in a smaller number than 0, and still you get a positive number. So given that they are both positive, you check the concavity. So since it's positive on this interval, it's concave up, and since it's positive on this interval and is also concave up, the whole graph is just going to be concave up. There is no inflection point because the graph does not change concavity. So for this problem, there are no inflection points. It's as simple as that. And here are some sample problems for you to try on your own. And if you didn't understand the video the first time around, please watch it again. Thank you for watching.